Hello, Texas Cyber Summit. My name is Dave Stokes. I am a MySQL Community Manager for Oracle Corporation. I've been on the community team for just over a decade. And sorry, I can't make it in person today. Oracle Corporation has a travel ban. If I could, I would drive down from where I live in North Texas and be down there with you on the Riverwalk. And today I'm talking about window functions for database analytics. I'm not going to assume that you have any knowledge of windowing functions or even that much about MySQL. Matter of fact, this should translate pretty much between any other relational database out there that has window functions. And let's get started. About me, that's a picture of me down in Ingram with the Stonehenge in the background and the Easter Island type figurehead that's out there in one of the parks. Once again, I'm on the MySQL community team. My Twitter handle is @Stoker. My blog is elephantdolphin@blogspot.com. And if you need to get a hold of me via email, it's david.stokes@oracle.com. And the slides for this presentation are available at slideshare.net/DaveStokes. Look for Texas Cyber Summit or windowing functions or both. And that's a nice little graphic image you'll see that I use. Someone created for me for another show. Now, this is an introduction. This is a subject that can take a great deal of time to master. This is the equivalent of walking into a second semester calculus class in college when you really should be in pre-algebra. But let's get through it as best we can. Now, I am using MySQL 8 for demos. As I mentioned earlier, this should work with other relational databases out there that have window functions. The good thing is that this is an introduction, and I'm not going too deeply into the analytics or the statistics, and they can be very complex. And good news for you is there's a lot of good books, videos, and courses out there that you can go through at your own pace. And by the way, learn to double check your assumptions. It's real easy when you're starting off to either reinvent the wheel or find something that you've made a mistake on your calculations and suddenly you're down the rabbit hole. And also take small steps. This is not something you have to know right away. Start playing with these and make little steps. And progress does take practice. To get really good at this, it's like learning a musical instrument or a martial art. You have to practice, practice, and practice. And the good news, if you're really into this, there's years of material out there for you to get really good at. So, analytics, what am I talking about? Well, according to Wikipedia, analytics is the systemic computational analysis of data or statistics. Now, there's a lot of good information in your data that you may not have done putting the two and two together. Sometimes the data is hidden. Sometimes you have to tease out the pattern. Sometimes you don't even know there's a pattern there until something pops up in your face. So don't get scared by the numbers and don't get scared by the complexity. We're going to start simple and build. Now, most relational databases have things called aggregate functions, which is what we in the MySQL used a lot before window functions came out 3 years ago in MySQL 8. There's functions to average numbers, find the max in a list, the min in a list, do a standard deviation, and some numbers and some other stuff. These are all fairly well described in the MySQL manual. I would ask you to go out and take a look at those. And these are pretty good for a lot of basic analysis. Don't sell them short. However, windowing functions have some advantages over these. Now, aggregate functions operate on a set of values, and that set is kind of defined by you, but it's kind of a limited way that you can set it. You'll see what I mean in a minute. Now, you can also use these with group by to kind of break them into subsets. So instead of getting a sum of all sales from a chain of stores, you can group it by the individual store. And one thing you'll see, again, a little bit, is it returns a single value for multiple rows, which may not be what you want, and sometimes it's misleading or confusing. Now, windowing functions, and this is just a list of some of them, are allow you to kind of group your data differently. You can do distributions, ranks, get the first value lag, which just means you skip over certain numbers before you start counting. You can use that with lead. You can get the nth value, quartiles or entiles, percent ranks, and other little functions. And you'll see how these are useful in just a little bit. Now, these use values for one or more rows to return a value for each row. This is might seem like I'm splitting hairs here, but you'll see what I'm talking about in a minute. Now, let's proceed on to the next slide. So here's some sample data. We're going to create a simple table called W1. It has 4 columns. B, C, and D are all unsigned integers, and A is a auto-incrementing value that's going to be we're going to use as our main number here. Every time we insert a record into W1, it'll automatically have A generated for us. As you'll see over here, we insert 3 records, and A is generated as 1, 2, and 3. Down below, we actually insert the data. Our first row is a value of 10, 100, and 1,000 for B, C, and D, and so on. So that's some very simple data. Let's do some analysis on this, and this will show you how you can basically step on your own feet and trip yourself. We're going to select all the columns from our table. We're going to sum up columns A and B, and we're going to nickname that A and B, which you see down here from the table. Now, if you look at this and you're paying attention and you had some caffeine in your system, you're going to see this first row is going to say A is 1, B is 10, and we got a value of 66. Hopefully you noticed that. Well, what went on there? Well, what happened is we took all our 3 rows and the 3 values for A and the 3 values for B and put them together, and that ends up being 66. This is where you can often mislead yourself and not get the numbers you want. Now, looking at this carefully, you'd say, well, A is 1, B is 10, so it should be 11. Why is it 66? Well, the computer, or the database server in this case, did not know that you, when you were summing these up, that you just wanted to do each of the rows by itself. And because your intentions weren't clear, it assumed you knew what you're asking for. Now, let's work with the group by function. What we're going to do is we're going to run the same query, but here we're going to group by the values of A. So everything that's for A related to the row, for each row, is going to be used. So it's going to take the sum of A and B for the first record and sum that. This is probably what we wanted with the first query. But as you can see, it's easy to misdirect yourself. Now, let's do a new data set. We're going to have a table where we have ID numbers again. We're going to have prices. And for each ID number, they're either in warehouse 1 or warehouse 2, and they come from vendor 1 or 2. Now, if we select our warehouses and we're subbing the price from our table that we created, and we want to figure out what the values are with the warehouse, we can do that. Now, if we add with rollup, it will actually give us the sum of the sum. So for warehouse 1, the sum of all the items in there is 13.59. The sum of all the values in warehouse 2 is 99 cents, or 99 whatever units you're using. And then you get the total price of the 99 plus 13.59 works out to 14.58. But when we roll up stuff, you'll see that we get this lovely null value. For those who aren't used to databases, in the early days, they wanted to use binary logic. So 1 would say something was there, 0 would say something wasn't there, and they say, well, how do you notate the stuff where you're missing data, the stuff we don't know, the unknown unknowns? So they came up with the idea of a third set of logic called null, which causes its own set of confusions. And unfortunately, databases tend to throw nulls like this when they don't have something else they can put in there. So in this case, if you're not used to databases, you do all the sums, you get the numbers that you're happy with, but this null will throw you. So be careful of that. Now, here's another similar thing. We're going to sum the price, and we're going to group it by vendor instead of by warehouse. And some results. Now, if you're used to this, it's great. If you're not used to this, it's bad. If you're using some sort of data analytic package that's not used to this, it's going to skew your results. And once again, null is confusing. Make sure you understand that null means that you don't have a value to put in there. So, windowing functions, let me warn you again, they are difficult. You have to practice with them. If you really want to build competence and understanding, you need to work with them for a while. And if you panic at first, don't worry about it. They are a learned skill. It's not like learning how to play a violin, where you actually need some innate talent to do it. This just takes a lot of sticking to it and working through it. So, if you're used to structured query language, the first thing you're going to notice about windowing functions is the keyword over. Now, in this case, we're going to select year, country, product, profit. We're going to sum the profit in two different locations here. And the first one, we're going to sum over, and the parenthesis here means everything, where it's empty, it means everything. This is total profit over all the columns. And then we're going to also sum over a partition by country. We're going to call that country profit. And if you look at the first three lines of this table, the year 2000, 2000, 2001 from the country of Finland, we have 3 products sold, a computer and 2 phones. The total profit is the sum of everything in the profit column. So over means everything. So everything in that column is put up there. So if you add up all this, you end up with 7535. Now, if you just want it by partitioning by the country, you get the value of 1610, which is our 1500 for the computer, 110 for the 2 phones, and there you go. There's what the profit was from the country of Finland. I'm going to apologize for my examples. I have to make them as clear as I can. For a lot of folks who are used to this is vast oversimplification. For those of you who aren't used to it, I'm trying to make it as obvious as I can. Now, let's go over the explanation again. Well, the first column we had, sum profit over. The over clause is empty, which treats the entire set of rows as a partition. It's global for that column. Now, the second over, we're going to partition by country. So we actually break it down by those rows. We get more granularity. We can direct the granularity. So you start defining how to partition your data. Okay, now I'll take a look at rank and dense rank. We're going to take this table here. The value of X has 2 zeros, 1 2, 2 3s, and a 4. And when we go to do our selection, first thing we're going to ask for is row number, which is a window function. And we're going to order it by X. We're going to call that row number. So our first value that we get, this 0 here, comes over here as a value 0. That's our first one we pull out. Now, databases, you sometimes get the data coming out as it's pulled off the disk, not in the way it was written down or any order that you set up unless you specify it. So in this case, our row number and rank number are the same. We read some more rows and we come down here. Second row, the value is 0. Its rank is 1 because that's the same value. Our dense rank is also 1. Now this is where it gets a little odd. Now our first value that we bring that's different than a 0 is a 2. This is our row number 3. This is the third row out of the table. Its rank is 3. You notice that these two are tied. So you have 2 first place and then the bronze medalist. 2 golds, 1 silver, 1 bronze. And the dense rank is 2. Well, why is that? Well, it's the second value that we have here. And if we go down to 3, our 2 values of 3, we have 2 different rows, so we have 2 different rows there. Once again, our rank is 4, so we've skipped over 2. These 2 are tied for 4th place, and our dense rank is 3. This is the 3rd unique set of values we've had. Now, this is kind of confusing, something to play with. So once again, if we select the row number as the row number, the rank over everything as the rank, and the dense rank, once again, you see how this breaks down. Our first value that comes out has rank of 1. Second value that comes out has a dense rank of 2nd, but its overall ranking is 3rd. So once again, the 2 gold medalists and then the bronze medalists. Now, you can add modifiers to window definitions on however you want to use them. Like in this example, we're going to select the first value of year, and we're going to order that by year ascending. And the next column, we're going to get the first value of year over our window, but we're going to, instead of ascending, we're going to descend. So you can add modifiers to your window function. Remember, over defines the partition. And what if you create a contradiction when you're doing this? In this example, we're going to get the first value, and we're going to order by name. So that's what we're going to do. Our definition is we're going to use a window called W, but that W, this window here, this is an alias for the window here, we've already set up as order by date. So if you set up something that contradicts in your parameters, it will tell you that that isn't allowed. Okay, here's another data set. We're going to create a table. We're going to call it X. We're going to have one column called X, and that once again is a serial field. And we're going to insert in 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 null values, which will tell the server, go ahead and insert 10 rows and auto increment this. So we have our 10 values of X. Now, once again, when we define our partition for the windowing function, what goes in the parameters is what defines what partitions the data, the granularity of it. And when we say over with just empty parentheses, that means the entire thing in the column. So if we're doing it on the entire table, when we do count X over everything, we're going to get 10 here. Well, why is that? Well, there's 10 different entries here. Now, if we sum up all this, the 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, the value ends up being 55. So here's basically, we're counting all the numbers of columns we have, and here we're summing all the columns. Now, is the value of 55 a piece of useful information we can use? Is it something that you can give off to manufacturer or marketing to have them make a valuable decision? Probably not. Now here's another example. We're going to take our same table. We're going to sum all the values of X and call that sum. And what we're going to do is we're going to create a window, and we're going to order it by that value of X. So our first record comes in. The value is 1. We sum that value. We get our value of 1. Second row is read. Column number 2, which has a value of 2. And we're going to sum the previous value plus this value. This might have some use for you in some other application. Now, there are some words and phrasing that are unique to windowing functions that don't make a lot of sense till you get used to using them. And one of those sets is rows unbounded preceding. So in this example, we're selecting X, which is our 1 through 10. The sum of those values, once again, as sum. But what we're going to do is we're going to sum the rows that we have with any ones that precede. So this is very much the same thing as what you just saw, but it's a different phraseology. So x is 1, the sum is 1, the new x is 2, so 2 plus 1 is 3, the third thing, 3 plus 2 plus 1 is 6. So you already knew rows unbounded preceding without actually knowing you knew rows unbounded preceding. Now, something else you can do to define your partition is to limit its scope. So like you're just looking, comparing data from 2 different quarters or 2 different years. In this example, we're going to select x and the sum of x, as we've done before. But now we're defining our partition as rows between one preceding and the current row. So our first record we read in, the value of x is 1 and the sum of that is 1. The second row we read in, the value is x and the sum of the current row and the preceding row is 2 plus 1. So the sum is 3. Now the third row, we're going to read in a value of x, and the value of that is the current row and the preceding row. So instead of where in the past where we've just put them all together, anything would be previous there, we're just going to sum these 2 rows. And you can also reach beyond your current row, which is rather unique to when doing functions. So in this example, we're doing our summing of x again, but we're saying now rows between one preceding and one following. So we read in the value of x, and we're summing the rows between the one preceding, well, there's none preceding, and one following. Well, we can grab the one following, but there's none preceding. So 1 plus 2 equals 3. If we go to the next row, we're going to take the row preceding, which has a value of 1, and the row following, which is 3, and put these 3 rows together, which comes up to a value of 6. Now with windowing functions, you define a frame of how you're going to partition your data. If you have unbounding preceding, that means everything from the current row to when you started reading that row. And if you do unbounded following, that's from your current row to the last row in the table. And you can also say n rows preceding or n rows after the current row. I love this little diagram here because it shows you visually what's going on. So if you do unbounded preceding to unbounded following, that's everything in the column. And if you remember right, that's just empty set of parentheses there. Okay, let's look at another data set. If we're going to select everything from our employee table, where we have Mo, Larry, Curly, Shemp, Joe, and Ted, and we put them in different departments and different pays, you're going to see how analytics can work on different pay groups. So let's select the name, the department, the pay, the sum of the pay, and we're going to partition this by department. So Mo, Larry, and Curly all are in department 1. They all get paid 100 units of whatever we're doing, and the sum for the department is 300. Now, if we look at the department 2, Shemp, Joe, and Ted, Shemp gets paid 110, Joe gets paid 50, Ted gets paid 8, and that sums up to 248. So this is how we're partitioning by department. Now, if we partition by department and order by pay, maybe you want to know the lowest paid person in each department, you can do that. If you look at department 1, they all get paid the same, so it doesn't really make a difference. Department 2, however, Ted here, remember, gets paid 50. So now we know he's the lowest paid person in his department. And we know whoever this is down here, I believe it's Shemp, is the highest paid person in the department. Now, you can use multiple windows if you want. In this case, we're using the syntax of over W. And down here, we define the window W as being partitioned by department. And we're also using over Y, which is rows unbounded preceding and current row. So we're going to go out and get the department, the pay, the sum of the pay over W, and the sum of the pay over Y. So first department 1, pay is 100, departmental sum is 100, that's 300, and our Y, which is rows unbounded preceding the current row. There's nothing preceding, so it's just the value of the current row. Second row, we bring in the second row of data. The department sum again, once again, is 300, and we now have these two first pay columns summed together. So we end up getting our value of 200. And if we go down yet another row, you see how this all builds. Now, when we get down here to this line here, we get to department 2. The pay is 110. The department pay, sum for the entire department, is 248. But our total payroll to this point is 410. Rank. Well, sometimes you have to rank stuff. If we're going to rank employees, and we're going to order it by our ID number, we're going to, since Mo has the lowest ID number, we're going to be able to rank him first. Probably should be ranking him by some other thing, but sometimes businesses do stuff like that. Now, once again, ranking by ID may not be something valuable, may not be useful. It probably has no quantitative reason for being, but something's happened. Now, let's rank them by pay descending. So, highest pay, rank number 1 is good old Shemp. And then we have 3 people who are Mo, Larry, and Curly, who all get paid 100. So they're ranked as number 2. Once again, this is kind of like the Olympic medal situation. Now, the third highest paid by rate person is good old Ted at 88. So, as you see, if you're doing dense rank, it would be a little different. But if we're ranking these by their values, Ted ends up being the number 5 ranked person. Now, let's come up with a percent rankage. And we're going to, once again, order by ID. And when you take the entire pay base and do that by most pay of 100, you get something that's below what will be recognized by the server. But if you add Larry and Mo together, you get roughly 20% of the pay. And adding in Curly and Shemp, you end up with 60% of the pay. So if they tell you that you have to trim 90% of your budget, probably Ted's the one that's going to fall out here. Now, make sure you're using the proper partitioning to get data that's meaningful. In this case, you probably, instead of ordering by ID, probably want to do it by their rank of pay. So let's take a look at percentage ranked by pay. So we're going to select name and pay and get the percentage rank that we're going to nickname as percent rank, and we're going to order it by pay. So this time Joe, being paid 50, doesn't show up, but Ted is 20%, and as we add Joe, Ted, and Mo together, we have 40% of our overall pay are now represented in this table. Let's take this a little differently. Get the percentage rank. We're going to order by pay and call that percentage rank. And then we're going to rank people over by pay. And we're going to rank them low to high. So Joe, pay of 50, doesn't have a percentage rank that shows up of meaningful value. And he's our lowest person, low to high. And we go down to Shemp, who gets paid 110%, or 110 units. He's going to be 100% of our pay when you sum all these together, and his rank is going to be number 6. Now, as I say, using the Three Stooges here is kind of convoluted, but I'm trying to give you an example of how the functions work rather than actual usable functions you're going to be able to use on your own data. But we're going to get a little closer there. Hold on there. So if we rank over everything, and we do a dense rank and a percentage rank, we can get some more information about who is the highest ranking person. So Shemp, highest ranking at a pay of 110. His dense ranking is 1. Now, Mo, Larry, and Curly all get a pay 100, and their dense rank is tied for second place. And you can see that their percentage ranking is 2% when you put them all together. Now, when you add in Ted, his rank is number 5, but his dense, or his rank is 5th, since there is no third or fourth. These guys tie for second, but the dense rank is 3rd. Now, let's take a look at cumulative distributions. Once again, we're going to order the percent rank by pay, and all the other ones by pay also. So Joe, whose pay is 50, doesn't show up high enough to be a percentage. He's the lowest person from low to high. His dense ranking is lowest, and his cumulative pay out of everybody of the entire payroll. If you just paid him, didn't pay anyone else, you've paid 16% of your total payroll due. Now, if you pay Ted and Joe together, your cumulative rank goes up to 33%. And by the time you get down to Shemp, when you pay him, your cumulative rank, or the sum of all these together, ends up to 1. Calculating percentages. If you want to do some of that, there are things you can do, like using a rounding function. We're going to take the amount of pay and over the sum of pay, so that's the pay per person, over the sum of all the pay over an entire column. We're going to multiply that by 100 and then just show the right two places after the calculation and call that percentage. So Shemp is paid 110 units of whatever we're paying. He's over 20% of the entire payroll. Mo, Larry, and Curly are each respectively 18.25% of the entire payroll. And poor Joe, with his pay unit as 50, is only 9.112% of the total payroll. So you might see how this works out a little bit better. Now, let's work out a quartile. The function is ntile, and if you put in 4, there's 4 of them, so you can call that a quartile. So if you put the people into a histogram, our 6 people here, and put them in a histogram, people in the first quartile are going to be Joe and Ted at 9.12 and 1606 of the total percentage of the payroll. And Mo and Curly are going to fall into the second one, and Curly falls into the third, and Shemp is going to be in the fourth quartile all by himself. Now, quartiles are real popular with a lot of statisticians, as it tends to give you fairly easy analysis of how things work. Now, let's take a look at the average and the difference from the average. So we're going to round off the average pay and call that average. And then we're going to calculate the pay that the person's being paid minus the average pay and call that the difference to average. So Shemp gets paid 110. The average of everyone in the business is 91.33 units of pay, and he is 18.67 above that 91.33. Now, Mo, Larry, and Curly being paid 100, they're each 8.67 units above that. Ted at 88 is 3.33 under the average, and poor old Joe is 41 under the average. Now, the lead function is takes a little bit of explanation, but you'll hopefully catch on to it. We're going to take our pay, and we're going to subtract the pay value of the one preceding, and we're going to calculate the difference to the next person being paid. So we're going to take the pay column and go one more down and subtract that value, so the pay of the next person in line, from the current pay. So Shemp gets paid 110, and the difference to the next person is 10. So this is 110 minus our lead of the next column, which is 100. So it's 110 minus 100, which is the value of 10. Now the next two are interesting because you have 100 minus the lead of the next value. So that's 0 and 0. When you get to Curly, the next person in the ranking, they're 12 below them. So that ends up giving them for Ted, the difference to the next person between him and the next is 38, and there's no one below Joe. But between Curly and Ted, once again, there's a difference of 12. So once again, lead gets row number n from the column. Now, lag is interesting in that you can skip a certain number of values. So if I lag A1 over W as lag 1, what we're going to do is we're going to skip, we're going to read in the first column, but not read in a value. And when we read the second column, our lagged value is A. As you can see, second column, the lag is 1. If we read in the third column, or the third row of data, the lag of 1 is the previous column's value for A. Now, if we lag 2, when you read in the first two rows, you're skipping over the first two, so you're going to have null or no value there. But when you read in 3, you're going to be able to subtract or come up with the point here to the value of A that was 2 behind. So a lag of 2 points up this column 2. A lag of 1 points up this column 1. Lead is the opposite of lag. This is where you're going to skip ahead. So if we read in our first row where A has a value of 1, and we're going to lead off 1, we're going to go down to the next row. And if we're going to lead 2, we're going to go off to the third row. Now, the syntax for the windowing functions, please read the manual page for this. It explains it a lot better, but the way these are ordered, you have to pay attention to, otherwise the syntax check will kick it out. And that is the end of this introduction. I got to apologize that I don't have clever industry-specific data for everybody, but I wanted to show you how these functions worked without getting too much into the weeds. Now, if you want to learn more, I recommend, if you're using MySQL, use the MySQL manual. If you are using a relational database, I recommend going off to Bruce Momgen, who's from the Postgres world. He works for a competitor kind of in the open source world, but he has wonderful presentations on windowing functions that are out there. I got a lot of my training from him, and I highly recommend these. There's another tutorial on windowing functions that's a little more detailed than I can be in my short amount of time. And also, this other intro to wind functions in SQL is worth a read. With an hour investment of your time, I really think you could have big dividends there. And whoops, this is Bruce Momgen's presentation. I recommend that. Okay, let me head down. If you want to try the MySQL database service on the Oracle Cloud Infrastructure, you can get $300 in credits that will last you free for 30 days. If you stay to the smaller machine sizes, that will last you a while. If you want to try the bigger stuff like our Heatwave analytics engine with autopilot, which is a machine learning based way of watching your queries and your instances to see how they could be tailored for better performance, that will chew up a little bit faster, but that's out there if you want to try that. If you want to keep track with MySQL, mysql.com, twitter.com/MySQL. We're on Facebook. Of course, we're on LinkedIn. We have roughly 21,000 people in the MySQL group on there. And of course, MySQL community.slack. And if you're in a startup, please look into oracle.com/startup. There's a lot of marketing exposure you can get, some credits for the cloud, and it's interesting, especially if you're a startup, some of the stuff that MySQL do to help leverage you into your future. By the way, I wrote a book. If you're doing the JSON data type with MySQL, please consider my book. The user guide or the manual is pretty good, but doesn't have a lot of coding examples, and there's lovely coding examples in there and how JSON works within MySQL. Has a lot of interesting features. It's a wonderful data type. You can actually store a gigabyte of data in a column in JSON format. And with that, I want to thank you. And if you have any questions, please do not hesitate to reach out to me. And the slides, once again, are at slideshare.net/Dave Stokes. Look for the name of the show and windowing functions. Thank you.